In this problem, 10 randomly selected specimens of beef, here we have our 10 specimens across the top, we're each given a couple different methods to determine the level of contamination of E. coli. So two different methods here, they call them A and B, and they used each of them on 10 randomly selected specimens. So we have our A and B over on the side here. Now, we're comparing the two, and it says, is there a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef? Provide statistical justification. You might be very tempted to say, oh, well, that's easy. List 1, list 2, 2 sample tests, 2 sample t-tests. Well, the problem with that is that there is actually a better way when you know exactly who the specimen is for each of the two methods, because you have a matched pairs design. Same specimen, method 1, method 2. Same specimen, method 1, method 2. And because you have that all the way across, instead of just using it as two separate unrelated samples, you can actually make better conclusions by subtracting one method from the other. And it doesn't necessarily matter which one you pick. I think the typical way to do it is to take the second one minus the first and create a list of those values. So in this case, 23.0 minus 22.7 is going to be 0.3, 0.3. This one here, 23.1 minus 23.6 is going to be a negative 0.5, or negative if the first number is smaller than the second. And you continue to go across and calculate these values. So again, we have a negative here. And you do that all the way across for each of these 10 specimens. And so you're going to end up with a single list of 10 numbers. That is the list that you will put into your calculator as your list 1. And you're going to, instead of doing a 2 sample t-test, you're just going to do a 1 sample t-test, or t-test. In a TI-8384. So when you run the t-test, you're going to enter in these 10 numbers, you're going to use the data values, use the data to figure out automatically what your mean and standard deviation and sample size are. And the test you're going to perform is going to be that the null hypothesis of no difference between the two, the null mean is going to be equal to 0. Now the reason that mu is going to be equal to 0 is because if these two were exactly the same, the difference when you subtract them would be 0. If these two are the same, when you subtract them, it would be 0, and so forth all the way across. So the test is, are these numbers essentially 0, or is it significantly different than 0? And in this test, since we are just looking for a difference, not one being greater than the other, we're going to say a not equals test. So we're going to basically say that mu is not equal to our null hypothesis. And if written not in our calculator way, I would rewrite these over here as our null hypothesis, mu is equal to 0, and our alternative hypothesis, mu is not equal to 0. So again, this is the way we usually write it on paper. The TI takes it in kind of this slightly goofy format, so this is just something to watch out for. So again, your statistical justification that it asks for back here is going to be the p-value that comes out of this 1 sample t-test that you perform on the differences of all of these data points. And again, that's called a matched pairs design.